Hello world, always seen Cortez coming live from Web3, and as always, going to be documenting what I learned throughout the day and giving some impromptu thoughts all throughout, right? Fairly sporadic. So I went to bed last night pretty late. I was tapped in, and what I was doing was essentially creating an NFT collection from start to finish, excluding the artwork. So it was all the code to get the NFT collection onto uh, Etherscan and pushing it to OpenSea if that was the goal. So that was a really good hands-on project where I got my firsthand experience of working with Solidity code. The benefit of this was that it's a benefit and a con at the same time that the code is there for you, which all you have to do is copy the repository and run some commands, and you will essentially create the collection, right? So it's being handed down technology. And that itself is a beautiful thing. Shout out to the open source community. However, as a builder and developer, um, getting something handed down to you is what's literally like that quote, like teach someone to fish, you feed them for, or sorry, give someone a fish, you feed them for a day, teach them to fish, you feed them for a lifetime. This is a perfect example of receiving a fish where it isn't exercise of thought, it isn't creation of code, it isn't merit of skill. So it was a really good experience to work with the code and get everything needed to make it work, which that itself is a challenge of downloading the dependencies. I was stuck on the ABI, which is essentially the machine code that the Ethereum virtual machine reads and will dictate the functions and the data types that the smart contract will pass on. So it's the translation between machine code to the smart contract variables of data. And um, it made me really challenge myself just to get the appropriate ABI code. There's a process to select and highlight the right code. That way it gets verified on Etherscan and it can be verified. So that was really good, but I also had that experience of, I didn't build it. I didn't exercise formal thought, and I didn't pull it out of my head to make it work, which is where you are a true builder. So what I did was I said, you know what, let me read throughout this code very diligently. So I read through the smart contract. The beauty of it is that everything that's there works, right? I just have to read it, understand it, interpret it, and process it, which is good. Now, where I was okay, like this is the area of smart contracts, but I want to understand everything at a grander scale as well. So I jumped over to learning more theory based. I learned a lot about security lately, and it goes hand in hand with smart contract because minting NFTs, as I've seen many collections, they have a lot of errors in their processes that make the project flop. And example, today there was a big issue with a collection that they were doing a Dutch auction. It was a really bad UX. Their goal was to reduce gas price, but people ended up paying a lot more in gas. So it's being aware of variables that are going to be at disposal when it comes to launching, and that's what's going to make a good executor, a great operator, is knowing what variables are there to work with, picking the best one and moving forward with it. So the areas I learned specifically were something called the self-destruct method, which is when a contract is called and it essentially disrupts itself. It was formerly called the suicide method, but they translated over to self-destruct, but the purpose is to remove the smart contract. Um, that I learned about encrypting data on the chain. When you create a smart contract and you create either a state variable, you can define the scope of it being public, internal, or private. And I didn't know this, but when you define it as private and it's on chain, that doesn't mean that it is private. So let's say that you make a variable called password and it's a string, and then you pass it on to chain, and you believe it's going to be encrypted because you didn't give the password itself onto the chain. But what ends up happening is that private really just means that it gets encrypted, and I believe is ASIC or something among those lines, and it could be unencrypted, and that variable that was supposed to be private gets unencrypted, and that to me was fascinating. Like, oh, this is what hackers do. This is how holes in contract or in code is made. So that was really, really interesting. Then I also learned about the reentrancy problem. I've learned about this probably 4 or 5 times, and it's complicated. It's something that I'm mapping yet to see multiple times to just fully grasp. I'm not 100% there. I understand the logic, right? The essence is that one smart contract one runs a function, and then it allows a second smart contract to be entered into that function, but that smart contract, the second smart contract, will create a function that keeps on looping before the function in smart contract one is finished. So it's a loop, and then what ends up happening is all the ETH in that smart contract either gets pulled out, or in the case of minting, a bot can just run plenty of executions. So that was really exciting as well. And it's an important thing in chain. Then I also learned about Merkle trees. Merkle trees, in my opinion, are very complex. I understand the theory. It's essentially encryption process to get to the top node to verify, and the objective of that is to store less amount of data on chain to pay less, and in that the root tree, it can go down to the branch, to the leaf, and if any changes happen in between, then the root will change and the hash outcome will not be the same by a small change, meaning that the transaction is not on chain. So that was Merkle trees. I also learned about callback functions, where they're the only function in the smart contract that could go unnamed, and usually their goal is to capture payment. So if the smart contract receives money, the goal is to have this callback function to receive the money. And last pointer I'll mention tonight was uploading from Ipfs to Pinata. So it went to essentially creating your node on Ipfs, but then moving it over to Pinata. That way, Pinata does all the heavy lifting about essentially hosting, and takes care of the backend processes of Ipfs. So Pinata is just like an easier UX for these processes, and it'll help render the images or the metadata of a smart contract. Okay, so I'll conclude here, keep it short. Every day something new, it's a lot. Right now I'm gonna get my hands dirty, do some building and exercise formal thought. I think that's where the experience starts becoming empirical, right? All right, so with that being said, thank you for watching, and I'll see you tomorrow.